In this video tutorial, we shall see the logic and the program to convert a hexadecimal or a binary to its ASCII equivalent. Let us first look into the logic of the program. So in case of hexadecimal number, we have 16 digits, right? That is from 0 to F. And here we shall consider the uppercase, right? And this hexadecimal number, we have to convert it into ASCII, right? So we know the ASCII of numerals, okay? For digit 0, it is 30H, 1, it is 31H, and so on. For 9, it is 39H. Similarly, for uppercase A, 41H, for B it is 42H, for C it is 43H, for D it is 44H, E it is 45H, F it is 46H, right? So let me take one example. So if I give a number as 30, right? This is a hexadecimal number. So what will be the ASCII equivalent of this? First I need to unpack this, okay? So this will become 03 and this will become 0. So if I want the ASCII equivalent of these two numbers, so I'm supposed to add 30, right? So if I add 30 to both, so I will get 33H, which is ASCII of 3, and I will get 30H, which is ASCII of 0. But when you have a hexadecimal number, something like this 4, let's say AH. So if I unpack this, so I will have 04 and 0A. That it is nothing but 10. Now I should get 34 here, right? So what should I add now here? I should add 30H, right? But when I get a digit greater than 9, that is any digit between A to F, so in that case I need to add 37H, right? So 37H plus A will become 41H, which is the ASCII code of capital A, right? So the logic is simple. In the first step, you separate those two digits, unpack them. If it is a number between 0 to 9, if the digit is from 0 to 9, add 30, and if it is from A to F, add 37H, right? So in that way we will be able to convert the hexadecimal number to its ASCII equivalent, right? So this is the logic of the program. Let us write the code for the same, and I plan to store the result as, right? So in memory location 30H, let's say I have the ASCII number 4A, right? So in 31H and 32H, I will store the result, right? Let's say in 31H, I will store the ASCII of 4, that is 34H. And in 32H, I may store the ASCII of A, which is 41H. So this is how I plan to store. So let me read the number move A, 30H, right? So first I need to unpack this. So for this I will have a subroutine, okay? I will say A call convert, okay? So this is the subroutine, right? So I have got the number in accumulator. Now I have to unpack this. So for this, we have to do ANL A comma hash 0FH. So in that case, I will get the first number. Okay, that is 0AH. Right? Now after this, I need to add 30 if it is from 0 to 9, and if it is from A to F, I have to add 37H. So for that, I need to compare this. Okay. So how do I compare is, I will compare, use the compare instruction. I will compare with hash 0A. Okay. Or you can also write simply 10 in decimal. Okay. Anything is fine. Okay. And I will say next. So what will happen is, if after ANDing, if the contents of accumulator is greater than 9, then the carry flag will be equal to 0. And if the content of the accumulator is less than 10, it means it is a digit between 0 to 9, right? So here I will check for the carry flag. So if carry flag is set, so the number is from 0 to 9. So jump on carry, or let's say to skip. Okay. So here in skip, so what I will do is, I will only add 30H. Add A comma hash 30H. Okay, for digits from 0 to 9. But if the contents of the accumulator is greater than or equal to 10, it means it's a digit from A to F. So I have to additionally add a 7. Right? So for digits from A to F. So what will happen is, here you will add 7 and here you will add 30. So totally you are adding 37H, so that you get the ASCII for that digit. Right? And don't forget to return. So this is for the first number, that is this number. Next I have to do it for the other higher byte, right? So I will again read the number, move A comma 30H, right? Remember, because I have called a subroutine here and I'm ANDing with 0F, right? So in earlier programs, after ANDing, I used to swap. Understood? Now I will swap here itself, swap A. So what will happen is, for example, if the number I have given is 4A, right? So here this will become A4, and when I AND here, I will get back 04, right? So that's the idea. And again you call A call convert. That's it. So this will convert the hexadecimal number to its ASCII equivalent, right? So let's execute and check the result. Let's say the number is 4A. Okay, one mistake we did is, we didn't store the result, right? So after returning, let me store this in 31H. Move 31H comma A, and we will store this result in 32H. Okay, I will take the number 4A, right? So I got 4A in accumulator. So I am calling the subroutine. Now see, I am ANDing, right? What I have got is 0A, right? So when I get a digit from A to F, I should add 37H. So I'm comparing the contents of A with 0A, right? So the contents of accumulator, if it is greater or equal, then I have to add 37. So in this case, it is equal. So this condition will fail because carry flag is 0. So it will add 7 and it will add also 30H. So you can see in accumulator I have got 41, and this I am storing it in 31H. Next I will read the number again. I got the number as 4A. Then I am swapping this. This will become A4. Then I will call this function again. It will AND. I got 04. Now 04 is less than 0A. It means it's a digit from 0 to 9. So I should not add 07, right? So because the contents of accumulator destination is smaller than the source, the carry flag will be set. And this condition will be true. So this will be skipped and I will add only 30H. So I will place back the result in 32H. Right? So this is the ASCII of 4 and this is the ASCII of the digit A. If you want, you can store this in 32 and this in 31. It doesn't matter. Okay.